The transistor is like an electronic valve that can be used as an amplifier or a switch. It can control a large current flowing through two regions of a semiconductor crystal, like silicon, with a small current applied to a middle region. There are many kinds of transistors. Typical is the bipolar, which has three layers: an input layer, a control layer, and an output layer. The layers are either N-type material, which conducts negative charges, or P-type material, which conducts positive charges. The layers are arranged like a sandwich in an NPN or PNP configuration. The individual layers are formed by treating pure silicon with trace amounts of impurities. Adding boron will create N-type material, phosphorus, P-type material. N-type material will have a surplus of electrons, whereas P-type material will have a lack. P-type material has a surplus of electron holes and is therefore positive. The silicon crystal is called a semiconductor because it will only conduct a small amount of current unless a change occurs at the junctions of the layers. In bipolar transistors, the input layer is called the emitter, the control layer the base, and the output layer the collector. When a current is applied to the emitter of an NPN transistor, electrons readily cross over to the P-type base, filling the electron holes. But when these holes are filled, the resulting negative charge repels further electrons that would come from the emitter. The transistor does not conduct. But when a small positive current is applied to the base, it will produce additional holes that will, in turn, allow more electrons to come from the emitter and pass through the base to the collector. Adding more or fewer holes into the base with positive current allows more or less current flow from emitter to collector, like a throttle controlling the speed of an engine. Because the emitter to collector current flow is up to several hundred times greater than the emitter to base current, the transistor makes a powerful amplifier.